All right, so as I said, what we're going to do today is we're going to run back through all of the titrations we've been doing. Okay, so I gave you a bundle, which is a formative assessment, and in this, we've really looked at our skills. So can we make a standard solution? Hopefully you can say yes, I can make a standard solution. That was experiment 6.2. Step 2 was, can you do a titration? All right, using a volumetric pipette, and in this case an acid-base indicator, and can you do some calculations based on working out the concentration of an unknown? And you should be able to tick that off as well, okay, if you've been watching and paying attention to what we've been doing in class. There's still a little bit of confusion though about where we're heading with this, okay, and what I wanted to try and do was to give you a big picture view, all right, about where or what we're trying to achieve with doing the titrations. And I'm going to start from where we want to end up, okay? So the ultimate design practical that you're going to come up with is going to be this one, acid content in, okay? That's where we're heading. So you're going to have to come up within your group is an experiment that will help you work out the acid content in something. Funny enough, I was looking at the advertiser the other day. I don't know whether you've seen this article, okay? But it's an article that talks about the acid content, you know, those sour drops, those things that you chew. And it's amazing about the acid content in some of these. They're talking about the effect on your teeth, all right? And I've had students in the past do things like acid content in Coke. Good experiment, okay? How do you do it? Well, you've got to work that out. That's part of learning, obviously. But you could do acid content in a sample of sour drops if you wanted to, of stuff you can actually eat. You could do acid content in wine. We are actually going to do a practice experiment, and once we get to this, our practice experiment is going to be acid content in vinegar. And you'll have 2 products of vinegar that you're given. There's a procedure for how to do that, all right? So it's not too difficult. If we want to work out the acid content of something in a titration, we've got to have a base to do that calculation because it's the stoichiometry. I've got to have a balanced equation according to my moldy Bible over here, all right? I can't do any calculations unless I've got this. I could do acid content in blood, okay? I could work out the pH of your blood. Can't do that anymore, okay? For obvious reasons, we can't deal with blood products. But you could do that. If you had a sample of blood, you could actually come up with an experiment to work out the acid content in blood. What does all this depend on if we're going to do acid content in? What did we actually work our way through as we were getting to this experiment over here? Because this is where it all happens here. What did we actually work out? What do we need to work out the acid content in this, or the acid content in this lolly, or the acid content in Coke, or the acid content in wine? What do you need to have before you can do that calculation?
Concentration.
Concentration of?
An acid.
No, we're trying to work that out. The base. Thanks, Sam. So you need to have something that is a known. You cannot titrate an unknown with an unknown. I'm trying to work out the acid concentration in this. So this is my known. Now, we got to it in a very long process, okay? I'll explain in a minute how we're going to do it for our actual practical, all right? So we need to have a known concentration of base in this instance. The base that we were trying to work out the concentration was, through a number of steps, was actually sodium hydroxide. That's our standard. We used it before and we're going to use it again. So this is my standard or my known concentration. Now, there is an issue with sodium hydroxide. We had a question last lesson about how come we can use sodium carbonate and we can just make up a solution with sodium carbonate, weigh it out, do a calculation, and boom, we get an answer. And we don't need to do anything with the sodium carbonate at all. We know that this is accurate. Can anybody remember why it is? Why can I weigh out sodium carbonate and just use it? Because I haven't standardised my sodium carbonate. I went and got it from the jar, I weighed it out, put it into a biometric flask, made it up, perfect. Sam?
Because it's an anhydrous.
It's anhydrous and it is pure. We talked about an analytical reagent. Okay? So I know that if I weigh out 1.2 grams of sodium carbonate, it's only got sodium carbonate in it. But I can't do that with sodium hydroxide. Sodium hydroxide absorbs moisture from the atmosphere. So whenever I make up a sodium hydroxide solution, which you will be doing by the way, you'll be using solid sodium hydroxide. You're going to make up a standard, all right, of the sodium hydroxide, and then you're going to need to standardise the sodium hydroxide with the HCl, because we all now know what the concentration of HCl is. So our practical is actually going to start here, all right? Because unless we know the concentration of sodium hydroxide, we can't do the calculation for the concentration of the acid in. Because if this is wrong, that's going to be wrong as well. The error will carry through. You call that a systematic error. All right, let's go back to the beginning again. So we made up a standard solution, and so this is part of your learning process. We used sodium carbonate that was pure. That was relatively easy, okay? We used this standard solution in a second experiment. So we took the sodium carbonate up here that we made. Here it is, okay? That was my standard that I'm confident, provided I actually weighed out 1.2 grams and I was very precise about how I used the balance and didn't lose any in the transfer and didn't go over the volumetric mark, okay, and made sure it was homogeneous, tick all those boxes, and then this we took into the second experiment. So this is what we call our primary standard. So we're confident the concentration of sodium hydroxide is 0.06. So we're going to use this to work out the concentration of the HCl. Why do I need to know the concentration of HCl? Well, we just worked it out, all right? Because I need to know the concentration of HCl to work out the concentration of sodium hydroxide. Like a bit of a domino effect, this whole series of experiments. And I don't know if I explained that very well, all right? So I'm going through it again. So, standard solution, we make it up, we use a standard to work out the concentration of the acid. We were just given the acid, weren't we? So we believed that the concentration of acid that had it on the bottle was 0.1 molar. All right? You didn't make that up. It was something that we're given. What do we find out? It's not 0.1 molar, okay? Through our titration, we've worked out that I think that the concentration is more like 0.2 molar, which I suggest is, it's a factor of 10 out, but that's what we had to do the standard, because we can't guarantee that if people put something in the lab for us or give us a solution, you can't assume that it is accurate. You need to do your own calculation in your experiment to standardise it every single time, because it's analytical. Remember we had right at the beginning, I said, you can't get this wrong. If you go on and you become a pharmacist or you're working in a lab somewhere and you're a factor of 10 out with your calculations because you didn't standardise the HCl, what's the consequence at the end? Someone dies, okay? And believe me, it's not very pleasant, not if you're in that family, okay? And got to be very careful, okay, about those calculations. So this is high accuracy, high precision we're working at now, all right? This is like how chemistry ends up, all right, in the real world. So we've used the sodium carbonate to work out the HCl concentration because we weren't sure whether it was accurate. We had to do a calculation. Now we're all confident. We've all concurred. Look at this. We're all pretty confident that we're within that range. We're reasonably accurate with our results. You could work out your accuracy. How would you do that? How would you know what your accuracy was? Omar? Yeah, I'd average them all out and then see how close you were to the average. The closer you are to the average, the assumption is, the more accurate your answer is. Okay? Can't use the word precise, all right? Because if you repeated the same experiment, let's say if you did the same experiment 10 times, we could talk about precision. How do we talk about precision in the context of a titration, by the way? So how did you improve your random error? What were we doing in our titration when we were doing our calculations? We were doing what? We were repeating our titration, weren't we? That's why you had a table, and you had to keep on going until what? Until you had 3 concordant titers.
But doesn't that increase?
That's increasing your precision. You're doing the same experiment again and again and again and again until your titer values are precise. If your titer values are going up and down all over the place, it tells me that your skill level is pretty poor. You haven't rinsed things properly, maybe you've actually not taken it to the bottom of the meniscus, maybe you've missed the end point, okay? So there's a lot of random error happening there. It's all over the place, okay? So how do we overcome that in a titration? We repeat the titration until we get our concordant titers. Bearing in mind the first one's normally a rough. That's an acceptable one. All right, so we've done our HCl. We use the HCl again. This is what we should be up to by today, I hope. All right? So again, once I stop talking, HCl is my known. In your calculation, you don't use the average, by the way. You've got to use your calculation, what your group got to carry this through. And I'm trying to work out the concentration of sodium hydroxide. Because our next step on this series of experiments is, once I know the concentration of sodium hydroxide, then I can go on, and I can actually do a test, this is the real chemistry here, then I can go and work out, you've got 2 products of vinegar that I'm going to give you, 2 different brands, and you're going to do a calculation, and you're going to work out the percentage of acetic acid in the vinegar. Okay? Most vinegars are somewhere between, to give you an idea, 4 to 6% weight by volume. Okay? And you don't know what that unit means. That means 4 to 6 grams per 100 mils of acetic acid. It's not very concentrated. Obviously, if it was, we'd have lots of blisters in our mouth every time we had fish and chips and chuck the vinegar on top. Okay? It's a diluted solution of vinegar. So we're trying to work out the actual concentration now in that particular unit that we'll look at later. So, to clarify it again, we were really trying to get to this point here, but we couldn't get to that point because sodium hydroxide, I can't just make up sodium hydroxide and use it like I can with sodium carbonate. It's got water in there. Okay? So I need to standardise the sodium hydroxide. How did I standardise the sodium hydroxide? Well, I had to do a standardising titration with a known HCl. How did I know the HCl? Well, that's where I had to standardise the HCl with a known base, in this case sodium carbonate. So it has this sort of ripple effect, okay, that one experiment's dependent on the other. Okay, any questions on that? What I want you to start to think about actually is within your group, when you get to the design experiment, which I think I've got it visible in the sector. Did I make it visible? I think I have. So there's been some awesome stuff done in the last few years, okay? I think when I was doing, I don't remember, when I was doing year 11 chemistry, year 12 chemistry, with my partner, we wanted to work out the acid content in sour sobs. It was a weird thing, all right? But the reason why we wanted to know sour sobs is because well, I don't know if you guys, do you eat sour sobs? Sour sobs, you know the yellow, you probably eat anything, don't you? you know the sour sobs. They're the yellow flowers. Param, go and pick a sour sob from the will you? Go and grab a sour sob out. No, not sour drops. Yeah, go and grab a sour sob for me. Yeah, just get one that hasn't been weed on. Okay. So this is what I did. All right. Listening. So what I did was that with my partner, and I had to work out what the acid was in sour sob first, because I need to have a formula that I can bounce an equation for. You can look it up. Okay. So we had to work out what the acid was, and then we had to work out a way of how do I get the acid out of a sour sob. And obviously we had to crush them and grind them up and filter them because there are lots of other rubbish in there, all right? And I just ultimately just wanted the liquid from the sour sob. And I had to weigh out like one sour sob or forget what we did. Well, we might have did a batch of 20 sour sobs that we crushed, and then we worked out the acid content for one sour sob. Okay, and then we went ahead because we must have some sort of a weird sense of humour then. But then we worked out what the lethal dose of sour sob would be. All right, if you sat down and ate lots of sour sobs, I'll never forget it. We worked out that if you sat down and ate 200 sour sobs, that's about this many, like that, right? What we worked out was that you'd probably get very sick at the end of it. It's not lethal, okay, but it's close to. Some people it could be. So we worked out how many sour sobs you'd need to consume based on a calculation of acid content, a bit more research, okay, that you could have before it did damage to your body, okay? So that could be something. Last year we had people working out the acid concentration, you know, the lemon squeeze you can buy, the stuff in the containers, lemon squeeze. A few groups worked out the acid content in lemons. Now, of course, that depended on the brand of lemon. When I say brand, like is it a Lisbon lemon or another type of lemon. Then they had to work out, how am I going to get the juice out of the lemon? Not easy. Or you could do something easy. But again, you have to work out how to do that in your experiment. All right? Or like I've said already, you might want to, you know, get a whole packet of these sour drops, and somehow you'd need to extract the acid from that. You need to work out. And then you would need to say, okay, if I've got a packet of 50 of these lollies and I've crushed them up, okay, maybe using a mortar and pestle or a blender or something, then I've got to put it into a solution, then I've got to titrate it against a known concentration of base. We're going to use sodium hydroxide. I could work out the acid content in anything. All right? So that's where we're heading for this. So I just want you to start thinking about what you would like to work out in your group. Okay? So you might work out, and of course you can't do the acid content in vinegar because that's our example experiment. But you can do acid content in wine maybe. White wine is acidic. Alright? So you just got to think of anything that tastes sour and you want to work out the acid content for it, you could design an experiment to calculate that. Can't use blood either. Alright?
Who buys the product?
Sorry?
Who buys the product? The wine?
The what?
Who buys them?
Who buys them?
Yes, okay.
You do in your group. Okay? What? No, so if you want to do the acid content in lemon squeeze, you will buy the lemon squeeze. We supply the lab, the equipment.
So we bring the wine.
You would have to, yes. Yes. I sit down, I'm not still talking.
No, sorry. When coming for this, I just like to take off the...
What's that?
It's a sour stuff. Or like a sour thing I was eating in the class right now.
Okay, so if this is something and you wanted to try and work out is this one of these sour juke things? So alright, so you've got to work out, so how am I going to get this into a form that I can titrate? Okay. Yeah, so it's sort of a jelly thing, alright? I don't know what's in it, but obviously there's some acid in there and there's some sort of a gel to make it acidic, right? Okay, so that means you might dissolve it in water. Maybe it will dissolve in water. I don't know. Can you get the door, please, Gordon? Maybe you'll dissolve it in water. This is what you've got to work out in your group. I don't know. Okay? So maybe dissolve it in water. Maybe you've got to cut it in fine pieces with a knife, that we can supply a knife. These are the sour sobs. Thank you. All right, so this is sour sobs. All right, so if you wanted to do, you know, the acid content in sour sobs, just wash them. All right. That's not really washing. All right. Either one of these. So if you're going to choose a lolly, you need to work out how you're going to get that in a form you can titrate. That's not easy. Okay, a bit more challenging for that one. But sour sobs, obviously you crush them, which is I think what we did when we did it. And then once you've got this, you probably need to work out how many sour sobs you use. So obviously I'm going to need a bit more than this many. All right. And then I would work out the acid concentration. Then I need to divide it by the number of sour sobs to work out how much was probably in one. It's not a very accurate way of doing it, all right? But it's the best way that we've got. So these have got an acid in them. You can eat them. What? You want some? That's sour? You can have one. I'll let you see what That's sour. So this is, I don't know why we did it, but I'm a bit hungry. All right. Everybody clear on that? Oh. Here, eat this. Eat it. All right, that's it.